So, again, like I said, this problem is going to be sort of like a model of what different types of questions are going to be asked on your homework. Alright, so my plan has been to get you guys to do this on Tuesday, but you know, some problems with technology and stuff didn't allow that to happen. So this Rob, any of you guys know who Raphael Nadal is? Well, he's a tennis player. He's a tennis player. He's a really good tennis player. And he's really good at playing tennis on what's called clay courts. Right? And clay courts, if you ever seen tennis, it's the courts that are like red, they look like dirt. Alright? Then you have other stuff like grass, which is at Wimbledon, which is, I think it's in Europe. It's in England, maybe. There's like hard courts that are like the blue sort of like tennis courts that you would see at the park or something. That would be hard serves out there. So what this says is tennis player Raphael Nadal is called the king of clay. Alright? For essential play on clay surfaces. But our question is, does he really have a greater ability to play tennis on clay courts compared to grass or hard court surfaces? Okay? So it gives us a two-way table, showing the results of his matches from 2009 and 2010. It shows us that he has 44 wins on clay surface, 2 losses on clay surface. That's pretty good. All right. So on other surfaces, he has 92 wins and 24 losses. Yes. Yeah, so when you're looking down there, you see like the part we're talking about hypotheses, your null hypothesis and alternative hypothesis. Now, the first thing that I would like for us to do is to create this graph so that we can make some initial conclusions about, you know, about his ability on clay courts versus other surfaces. So, in order to figure out if someone has a greater ability, in sports, oftentimes ability, like we're talking about, to be good at a sport, you win. Okay, so we want to look at his winning percentage here, and we want to compare his winning percentages between clay surfaces and other surfaces. So the first thing in order to create this graph that we would need to find would be what? The winning percentages. Okay. So Trayvon, since you volunteered to tell us that we need to find the winning percentages, how would we go about finding the winning percentage for a clay court? 44 divided by 46. And we did that because we know that in order to find the winning percentage, and again, this is if you want to make this is part of your notes, so you want to have all this stuff down.
Mr. Campbell,
So the reason we do that, what? Focus. The reason we do that is because we take the wins divided by the total number of games that he played on play. So to figure that out, obviously, I don't know what 44 divided by 46, what percent that is. So you can take your phone out right now, but we'll get you calculators and you start this on your own. 44 divided by 46 would be 95.6%. So we'll round that up just to be, make it easier, 97%. 97? Yeah. So on the clay court, he wins 97% of the time. That's pretty good. Now, we're going to look at the other surfaces. So other. Now, Christian. Yeah. Figure out the other. 92 divided by 116. 92 divided by 116. So wins divided by total. Yep, wins divided by total. So 92 divided by 16, or 116 is going to be 79%. So 79%, pretty good, but that's significantly lower than 97. So to graph this, we would need to put this winning percentages on a bar graph. Yeah. What do you ask? Bar graph. Okay. We don't need to find the losing percentages here, because right now it's fine just put the winning. You could find the losing percentages and put those on there, but we're going to compare the winning percentages. So take this 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And we have to label this winning percentage. And we have clay, and we have, okay, so clay was 97%. And the other winning percentage is 79, so 10, 20, 30, 40, 50, 60, 70, 80, 79, 80. So there's our graph. Now, it asks you to briefly describe what we can notice here. What can we notice? What general conclusion could we draw just by looking at this graph about the winning percentage?
He wins more games.
So he wins more games. He performs better on clay than other types of courts. Now, we can't say that he has a greater ability because of this, because we haven't considered the idea of random chance. But the conclusion we can draw here is that obviously he performs and wins more games on clay courts than he does other courts. Okay? So that's all we can do. We can't say anything about ability because we haven't ruled out random chance. But what we can say is that obviously he performs significantly better on clay courts than other courts. Now, the next thing we need to do, so this is, we're drawing some initial conclusions now. So the next thing that we need to do is we need to start creating some hypotheses. Because in order to figure out to draw a conclusion, we need to have something to test. Yes, Christian.
So basically, we're doing the same. No, we're doing the same thing as H5. I mean, that same.
Yes.
Alright.
You're not doing the same thing, you're doing that. So, as Christian said, yes, we're coming up with H0, H sub 0. That's our, anyone remember what that stands for? Null hypothesis. So, I don't want you guys to get into the habit of just saying H sub 0. I want you to know that's the null hypothesis. Because H sub 0, you might just get into the habit of saying that and not really know what it is. So our null hypothesis, can someone come up with a null hypothesis here? Someone besides straight line right now. Faith. Hold on. Faith.
Wait, Ralph has the same ability to play on clay courts from here to other. Or should we say gravel?
What do you think? The background null has the same ability to, did you say play or win? Yeah, win on clay courts and other courts. Yeah. Good. So again, what are the two? Okay, well, first of all, what's the most important thing to remember? Our null hypothesis is going to have what about ability? Same ability. All right. It's also going to have and at that. But you need to make sure when you're writing your hypotheses that you put both parts. You can't. Like, Faith would have been technically right, but not really right. And she said Raphael Nadal has the same ability to win on clay courts. Same ability on clay courts and what? Right? You can't say someone has the same ability if you don't tell us what you're comparing to the ability compared. Okay? So now H sub A. What does H sub A stand for again? Alternate hypothesis. Okay, so we're going to have Dominique,
Hold on, I wouldn't do that.
because it looks like you're ready to be on your toes.
No, this would be, I want to have my own.
What changes though? You go from same ability to what? Okay, and what else changes? And changes to man. So, Raphael Nadal has a greater ability to win on clay courts than other courts. Okay, good job, Dominique. Now, everyone good on the hypotheses? How we create those? So, here's the thing, Christian. We have made an initial conclusion. We've now developed some hypotheses. So now we have to test that. And in order to test our hypotheses, what we need to do first is find our test statistic. Alright? Because if we don't have our test statistic, when we get our dot plot, we will have no idea how to read the dot plot. So, anyone remember how to find the test statistic?
Yeah, 97, when you do play, minus,
Wait, no, you do another division. So, 44, okay.
We did all that.
no, bro, 97 minus 7. I think it's 97%. 97% minus.
We did it.
Okay, cool. I know this is telling you now what to do.
Yes, you're right. We do have to find the winning percentages first. Now, it just so happens in this problem, we found them for the first part. So we're going to subtract those two. So we're going to have 97 minus, so 97% minus 79%. And that's going to give us what? Anyone know that off the top of the head? 18, 19?
18% left.
What?
18%. Okay, so that 18% is our test statistic. So that test statistic represents the difference between our winning percentage on clay and our winning percentage on other courts. Now, here's my question. What if that was negative 18? What does the negative sign in front of it? Not bad. Perfectly fine. How, if it said negative 18, let's just say the percentages were flipped and it was, clay was 79. It means yes. It means that he did better. So if we would have subtracted these and got 18 or negative 18, that would mean that he did better, he won more and performed better on other surfaces compared to clay surfaces. Okay? So, you guys remember how we used those cards to simulate the Arizona Cardinals?
Yeah.
So, and remember how back in the day, like last week, we asked you guys, or I guess a little bit more than last week, but we asked you guys to explain how to simulate our situation using random numbers or a spin. Well, we used our note cards to simulate the Arizona Cardinals. Yes. Okay. So, what I want you guys to be able to do is describe how to simulate the distribution of the test statistic using note cards. So how do we do that? Okay, so remember,
This is what we do. We take, you put some number of, you take 162 cards,
Yeah.
divided by 2.
so you say 162 cards?
136 cards. What's the total?
I'm not sure if the winning or loss of the card.
Nah, you take the total, and you divide by two, the win and loss.
Yeah.
Play, you play, and other stuff.
Well, I like the idea of taking the total number of cards. Alright? Why do we take the total?
We take the total because.
We take the total because how many, like,
That's how many.
think about the Arizona Cardinals. How many, they went 9-7, which was 16 games. How many cards we had? We had 16. Right? So we need the total number of wins and losses. So let's think about it. So I like, yes, we're gonna take 162 no cards. Okay? Take 162 no cards. Now, what did we do with our no cards? We had 16 total. They went 9-7, 9 wins, 7 losses, and we wrote win and loss on the cards. How many cards said win?
40.
I'm talking about. They went 9-7. We had nine cards that said win, 7 cards that said loss. All right. So we took the total number. So the Arizona Cardinals, we took the total number of cards, and then we took however many wins we had, wrote win on it, and however many losses, wrote loss on it. So what would we write on our card? Well, that's just on play. How many total wins did he have? 136. And how many total losses did he have? 26. Because we have, let me just look at it. We have 162 wins. If we wrote 46 on there, and plus, if you wrote 46, that's not considering, like, you wouldn't write wins 46 times because two of those are losses. Alright, so we have 136 total wins and 26 losses.
So we're like 136 W's in this call.
Yes. Uh-huh. 136 W's. Well, I guess let's put right W on 136 cards. And how many losses did you have? 26. So we'll put L and L on 26 cards. So after that, I had you guys put, because he played 8 home games, the Arizona Cardinals played 8 home games and 8 road games. So I had you take randomly, just shuffle them up, and I had you put 8 cards in one pile, 8 cards in another pile. Okay? Because you had a home pile and you had a road pile. What types of, are we going to have home and road piles here, or are we going to have something different?
Something different. Play or other?
We're going to have clay and other, because either he played on clay or he played on other. Alright, just like they either played at home or they played on the road. So clay or other. So I'm going to create a clay pile and an other pile. How many cards am I going to put in the clay pile? 46, because he played 46 games on clay. How many am I going to put on other? 116, because he played 116 games on other surfaces. So we're going to make a clay pile with, what did you say, 46?
Yep.
46 cards. and other pile with, what did I say, 112? 116, I just checked to make sure you guys were just saying yes on that. 116 cards. Alright. Now, there's one last thing we have to do. Remember, in order to create our dot plot, what we did is we wrote down our home, with the Arizona Cardinals, we wrote down the home winning percentage and the road winning percentage and calculated our test statistic. So what do we need to do finally with each of these tiles? Flip them over, we need to calculate what?
100.
So we need to calculate the winning percentage on clay and on other courts based on what's in that pile. So finally what we need to do is calculate winning percentage in each pile. Okay. Now remember, obviously, we don't want to have to make 162 cards. And obviously, we don't want to have to flip these 162 cards into piles 100 times. And obviously, we don't want to calculate the winning percentage 100 times. Nope. So here's what's going to happen. Two things. You're either going to get the dot plot, which I gave you in this next part, or you're going to have an iPad to create a dot plot. Never am I going to make you do this by hand. Okay? So, what we do, and again, you have to remember, what was our test statistic? What was the test statistic we got? 18%. So the difference between Raphael Nadal's winning percentage on clay versus other was 18%. You have to remember that in order to be able to use the dot plot. Okay? And then, sorry, I'll make sure you get all this stuff. Alright? So, we have a dot plot now. Okay? It says 100 trials of the simulation were conducted, and the value of the simulated test statistic for each trial was recorded on the dot plot F. Right. It says describe what information this dot plot gives.
This is where I got stuck.
Okay.
They use a simulated difference one.
They give you what?
Simulated difference.
Good. So here's a huge hint. When you guys get these types of concepts, probably out of the book, they tell you what the dot plot is showing you. Okay? It tells you right here. The dot plot shows the difference in winning percentage. Okay? So, now it's important to note, it's the difference in winning percentage due to random chance, because the simulation is all random. So, how can we write it down? Well, what we can write down is, we can put, the dot plot shows, so, what does the dot plot look like? Here. The dot plot shows, I'm not going to think too hard. I wish I could copy that straight over there. The simulated differences in winning percentage. I'm just copying what's underneath the graph. All right. I'll do this. Differences in winning percentage due to random chance. And I guess one other important thing that we should put on here is assuming his ability
Isn't that like in the, that was
is the same. Alright, so you always assume that his ability is going to be the same. Okay, so the next thing, so if we look at this dot plot, we know what it's telling us now. Okay, it asks, instead of using the dot plot and the test statistic, our test statistic is what? 18%. So we need to estimate and interpret our p-value. Okay. So what we do now, we didn't really get to do it. What we didn't get to do on. Yeah, so yes, the p-value is going to be how many times on our dot plot he gets 18%, or 18% as a decimal is 0.18. Alright, how many times he got that or higher, because our hypothesis was greater ability. So we look to see where is 18. Well, 10, 11, 12, 13, 14. So 18 is right there. So 18 or higher, he got 18 or higher one time. So one time out of 100. So our p-value, the value of our p-value is equal to 1 out of 100. Okay? Now 1 out of 100 is equal to 0.01. Okay? And if we write that as a percent, that's equal to 1%. Huh? Now, we found it, so we estimated it, but now we need to interpret it. What does this actually mean? Well, what this means is that there is a 1% chance that there's a 1% chance that there is going to be a difference of 18% or higher between his winning percentage on clay versus on other surfaces. So how do we interpret that? Well, this means that there is a 1% chance that the difference between his winning percentages is 18% or higher. Okay? Alright. So, what we now need to do is we need to draw a conclusion. Okay? So remember, back in the day, we just looked at the dot plot and see, oh, there it shows up on the graph. So that means that there is due to random chance. Now I said at the beginning of this, this is going to be a little bit more mathy. So we have to base our conclusion on our p-value, not just what the dot plot looks like. So what we do is we're going to go ahead and take this 1 out of 100, 1%. And I gave you a list of 3 conclusions you can draw. Let me go back to this real quick. Okay. Our list was if the p-value is very small, meaning our p-value is less than 1%, less than, not less than or equal to, less than 1%, then what we're going to do is we reject the null hypothesis and we accept our alternative hypothesis. There is convincing evidence that we can accept the alternative hypothesis. Okay? Well, was our p-value less than 1%? Huh? It was less than?
It
Was 1%. It's equal to. So it's not this. So if we look at the second one, it says if the p-value is small, okay, not very small, it's not just small.
So like random chance is not fun.
This I believe. Yeah. What it means is by random chance is not plausible. It means that this performance was not due to random chance. This performance was because his ability increased. Okay? So it says if the p-value is less than or greater than or equal to 1%, but less than 0.05. Well, we just said ours is equal to 1%, right? So this is our conclusion. So our conclusion is we are going to reject our null hypothesis. You want to make sure you put that. So we are rejecting our null hypothesis. So we are rejecting our null hypothesis. Okay? Now, if we reject our null hypothesis, that means that there is convincing evidence to support our alternative hypothesis. So what that means is we have convincing evidence that he plays better on clay. Okay. Yes. So, what I want you guys to notice is this. On our dot plot, there's a dot that shows up. Previously, what we would have said is, it's due to random chance. Because it shows up on the dot plot. It's not higher than the highest one. However, now that we've gotten a little bit more mathy, we have something that's a little bit more precise. All right? We're changing our outlook a little bit. We're saying, okay, yeah, it does show up one time, but that one time is so very small that we can reject our alternative hypothesis. We can say it's not because they have the same ability. It's because Graviano's ability to win on clay is greater than his ability to win on the surface. Okay? So what you guys are gonna have the ability or a chance to do now is you guys all received the daily sheet on Tuesday that had 4 problems on it for homework activities. And you're also gonna get a paper today that is home, well, it's classwork, but if you don't finish it, it's homework. That is also gonna be graded. The problems are all similar to this. So what I'm gonna do is I'm gonna give you guys time to practice this in class today. And if you have questions, you can ask, you can get help, and if you can work together. And you can use this to help you. So what you need to do is, one, you need to make sure that you have your homework, your daily sheet from Tuesday, also in your pass out. Yeah.